Welcome to class PM. The previous class we have studied about the magnetic effect of electric current, and we have also seen how to make an electromagnet, right? We'll use the same principle in the electric bulb. And this class we are going to learn about electric bulb. We all know that there is a bell in every school which rings after every period, and the long bell indicates that it is time to home, right? And most of us actually wait for the long bell so that we can go home. But nowadays I don't think so, because most of the children love being at the school, because you have various kinds of activities, fun activities which are being taken up by the school, so that you love being in the school with your friends. But still we used to wait for the long bell to go home. So this is the actual electric circuit of an electric bell. So let us see what are the things which are needed to make a circuit of an electric bell. The first thing, take this, it consists of a coil of wire which is rounded around a iron piece. So the iron pieces are wound up with a coil of wire, where these iron pieces act as electromagnet. We know that the electromagnets are usually made when electricity is passed through. Right, we have seen an activity, the iron nail becomes an electromagnet when it is wound up with a wire and electricity is passed through it. So the same way, this purpose of winding the coil of wire around this iron is to make it magnetized, so that it will act as electromagnet. And you see that there is you have a metal strip, iron strip. We know that iron is a good conductor of electricity, iron is a good conductor of heat, right, and electricity too. So there is a screw, and you have a hammer which is attached with to the metal strip or the iron strip, and the ball of the hammer is said to be the gong. It is called as gong. What is it called? The gong. So the ball of the hammer is said to be the gong, the head, or you can say the head of the hammer is said to be the gong. You see that the screw is attached to the metal strip. Now this is a setup for an electric circuit of a bell. So when the coil which is present, it will act as a electromagnet as said. And the iron strip which with the screw, see, the iron strip which is present with the hammer at the one end is kept close to the electromagnets. So when the iron strip is in contact with the screw, when the iron strip comes closest to the screw, you see that the current flows from the screw to the hammer, where you see that the gong of the hammer will hit the metal plate which is present, so that the sound is produced due to the vibration. Yes, the sound is produced during the vibration. As it strikes, you produce a sound. Okay, as this gong is hitting the metal plate, definitely there is a vibration which has been produced, due to which you see the sound is produced, and you can hear the bell ringing, right? I'll repeat, the metal plate which is present is provided with a screw, and the screw, when it comes in contact with this metal plate which is connected to this, which is placed nearer to the electromagnets, you see that when there is a flow of current, this metallic screw which is present, it will make the gong of the hammer to hit the metal surface or metal plate which is present, which will strike the metal plate and produce vibration. And when the electromagnet pulls the screw, you see that the circuit is broken. That means there is a break in the circuit. So this electromagnets pull the screw, that means there is a break in the circuit. So the coil can no longer be an electromagnet when there is no current. That means they cannot attract the iron strip. So the iron strip again comes close to the screw, where the electromagnets will help in attracting the iron screw, and when there is electricity passed through it, you see that the gong of this hammer hits the metal plate, and again the bell strikes. So this is how you can hear the hammer bell ringing. So see, when the electricity passes through this circuit, you see that the screw comes in contact with the metal strip. The metal strip again, what does it do? The metal strip will again make the gong of the hammer to hit or strike the metal plate, and when it is struck, when the gong strikes the metal plate, you see the sound is being produced within you can say that with quick successions. So that is how you can see the electric bell ringing after every period. Nowadays we have electric bells which are set with devices like time period. So every 40 minutes you get a ring, right? You need not go and switch on the bell and ring it. You can just digitally use it. You can insert the timing so that they keep ringing at that particular timing. So this is how this electric bell is used in the schools, or this is the working of the electric bell. So it has to be connected to the electromagnets, where the electromagnets are made by taking the iron pieces and winding the coil around it, which will act as electromagnet. They are connected to the series of batteries, and then you see that there is a metal iron strip and a screw which are attracted towards the magnet. They come closer, and when there is electricity flowing through it, the electromagnets attract the metal strip, and what happens to this hammer? They go hit the metal plate, the gong hits the metal plate, and immediately you can hear the bell sound. And once the current flow is stopped, you see that the metal strips moves away from the electromagnet. That means the electromagnet is no more a magnet, so that it can attract iron strip. So when there is no attraction of iron strip, there is no chance of the bell to ring, right? So again, when you switch on the circuit, when you on the circuit, you see that the electromagnets which are present, they attract the iron strip which is present near the screw, where this gong again goes and hits the metal plate, which is seen at a very quick successions. So this is how the electric bell works.